Alrighty. I'm a sucker for history, so this is just a little bit of periodic table history to get us in the groove to see where things come from. We'll have another one to talk about the modern periodic table, so hopefully this is short and sweet. Try not to be too ridiculous about it. Um, there it goes. Uh, 10 elements have been known since before people started writing things down. So we call this antiquity. They've been known since longer than we can think about stuff. There are these 10: antimony, carbon, lead, copper, mercury, silver, iron, sulfur, tin, and gold. I find it interesting that the next element discovered was arsenic, and this was in 1251. Um, and then just as a reference point, in 1776, only 24 elements were known. So a lot of chemistry is relatively new from a grand scheme of human history. Um, in the early days of all this, uh, people were looking at elements and trying to figure out if there are relationships between them. They were noticing that, these things behave similarly or they have similar properties. Uh, and they tried to dig into what this pattern was. And one of the first guys to do this was Dobereiner. Um, he was German, and this is around 1829, and he came up with what he called triads, or sets of three elements that he figured belonged together as a group because they uh, had similar properties and similar qualities and all of this fun stuff. There's four of them listed here: calcium, strontium, barium, chlorine, bromine, iodine, lithium, sodium, potassium, sulfur, selenium, and tellurium. And it's just interesting to see how early this was as we did it. This is before we have any sort of periodic table or anything. Um, when he published his paper in 1843, he had found and studied and presented 16 uh, of these triads. Later, not too terribly much later, was a guy by the name of John Newlands, and Newlands was uh, very interested in music, and he was kind of a musician as well as an English chemist. And um, what he realized uh, was that, or what he noticed, I don't know, realized, noticed, whatever, was that the properties of elements tended to repeat, and there was a repeat unit where every eighth one was similar and started the pattern over again, if that makes any sense whatsoever. And so he brought his music into this and um, called these octaves, and he had sets of octaves that were, a string of elements that were similar and increased by uh, mass, or I guess he gave them numbers, right? We have numbers here. Um, and, he was teased because of, you know, the music connection, but I found it interesting because, we can see these things repeat um, in current technology as we do this. Eventually, all this comes down to a Russian guy by the name of Mendeleev. We've probably heard of Mendeleev before. He's one of our first put it all together periodic table people. Um, and in 1869, and the Russian Chemical Society put out this paper, The Dependence Between Properties of the Atomic Weights of the Elements, um, and really kind of tied everything together. Okay. Um, this periodic table that he had was arranged by mass, and it kind of put things together. And if you look, you can see uh, Dobereiner's triads in here. See if I can find them. Okay, here's chlorine, bromine, and iodine together. Here's sulfur, selenium, and tellurium together. I don't remember what the other ones were. Lithium, sodium, potassium, no, calcium, strontium, barium was one. What's the other one? Lithium, sodium, and potassium are over here, right? And so they're together. Okay. Um, Around the same time, a German chemist by the name of Meyer did this, and they were kind of rivals at the time trying to put this together, but ultimately Mendeleev won out the historical battle. And really, we kind of just credit Mendeleev with this, and I forget exactly why, but even though Meyer was slightly first. Oh, I remember why. I'm an idiot. Okay, here we go. Um, Essentially, what this comes down to is now we call this thing called periodic law, right? If we uh, arrange the elements in order of increasing mass, their properties or sets of properties recur periodically, and that's kind of where this period comes from. There's a regular pattern to everything in the periodic table, and we're going to start mining this periodic table as we do stuff. There was a couple of things in here that Mendeleev liked to point out. One of those was that iodine and tellurium didn't really, they're right here, didn't line up the way he wanted with mass because the properties didn't make sense with their partners. Okay, so Mendeleev suggested that the mass of tellurium was wrong, and put in a corrected mass on the table. And it wasn't until later that Henry Moseley, an English physicist, arranged everything by atomic number, and that fixed everything. Okay, and we'll talk about that later. Probably the number one thing that made Mendeleev's table so successful was that he realized at that time in the 1869, 1870s that chemists probably didn't know everything there was to know about elements, right? And that there was probably elements left to be discovered. And he left gaps in the table to say, okay, there's probably an element that has these kind of properties, and it would go here once we find it. Two of those big ones are here. These are gaps. And he called this Eka aluminum because it's one under aluminum, and Eka silicon, which is one under silicon. And this is really why Mendeleev's table caught on. Like, well, he left gaps here. And it wasn't too terribly later. It wasn't too terribly later that people actually found these elements and discovered them. Eka aluminum, now we know as gallium, was found in 1875, and Eka silicon or germanium was found in 1886. So this wasn't even 20 years after the periodic table had first come out, and the properties that Mendeleev had predicted nicely line up with the actual properties of the newly discovered elements. And this is why Mendeleev gets the credit, is that he was able to predict. Okay. That's really it for history. We'll get into the modern periodic table in another video. Okay. I'll see you later.